Hello everyone. Today I'm going to do my presentation about our project proposal. Our project would be a self-powered underwater data center. Here are the group members. First, I will talk about the contents. First, what is a data center? We will give some definitions. Then, why is it interesting to have this data center underwater? What are the benefits? And finally, how is it supposed to work in these conditions? What is a data center? A data center is a building, a dedicated space within a building or a group of buildings used to house computer systems and associated components, such as telecommunications and storage systems. Data centers are an integral part of the enterprise, designed to support business applications and provide services such as data storage, management, backup and recovery, productivity applications such as email, high volume e-commerce transactions, powering online gaming communities, and of course, big data, machine learning, and artificial intelligence. So, why is the underwater configuration interesting? We can discern two cases. Having the whole data center under the water permits to keep it safe in case the data is confidential and national security related. In addition to the natural protection, which is the seawater all around, they can use the fact that the location of the data center under the water is very complicated to find. The other case can be a company, a very huge company like one of the 5 GAFAM, which uses a large amount of data for their purpose and wants to reduce their costs. The underwater data center already exists in the world, in China, of course. It has also been released before in 2018 by Microsoft with the project Matic. It got very good results, especially about the lifetime of the components, which lasted much more than usual components in a data center on the surface. Here is a picture of underwater data center from the Chinese company Highlander. And here under we can see the inside. There is a gathering of computers. The company Highlander is planning on commercializing them soon. Their vice director, Xu Tan, said, seawater can be used to reduce energy consumption by about 30%. They already use the seawater for the cooling and save a lot of money and energy. But what would it be if we use this seawater to produce the electric power the data center needs? This is the question. So how will it work? A data center needs to be powered with electric power. The precedent one we saw here is connected to the ground with an electric cable using the electric power produced on the ground, on the surface. In our case, in order to make the data center self-powered, we imagine that the power could be provided using the power of the seawater. So the electric power could be generated using the tidal current, which will allow the autonomy of our data center and also reduce costs above its energy consumption. Let me present you some different types of tidal power generation methods. The first one is the tidal stream generator. It is a structure with a turbine that can produce up to 1 megawatt of electric power. It will use the water stream to generate electric power while the turbine is rotating. The tidal barrage will use the tidal current to hold the water on one side with the sluice gates And when the current is reversed, it will let the water go through an opening that will make rotate the turbine and create electric power. The dynamic tidal power, it will use the coastal currents to generate electric power with turbines also. The dam is installed perpendicularly to the coast here. And it forms a T, the letter T. The current is going like this, depending on the day moment. And going this way, it will go through openings and generate electricity. Here's a short video.
Of 10 lang. En we dachten, zou dat misschien een nieuw type getij-energie kunnen betekenen? Zo is Dynamic Tidal Power eigenlijk ontstaan.
Dynamic tidal power is designed to generate electric energy from the kinetics of tidal water. A long dam of at least 30 kilometers, perpendicular to the coast, interacts with the tidal flow to create a hydraulic head, a barrier parallel to the coastline at the far end of the dam. Giving it a T-shape amplifies the head on either side of the structure. This hydraulic head, together with the shape of the tunnels, results in the acceleration of water that drives the many turbines in the dam. Marcel Stever is professor.
So this was for the dynamic tidal power. And the last option could be a tidal lagoon. The principle is about creating a perimeter on the water near the coast with a dam, you can see here. And use the tidal current movement to make the water also go through openings with turbines in it and create electric power. Another aspect is important, the safety. The system is supposed to work continuously on the water and contain very important data. Like we mentioned before, being on the water guarantees a safety for the data. So while being on the water, we want to avoid all type of risks. The structure should be strong enough to be reliable under the water and resist water pressure, and also allow a perfect waterproof isolation. Another feature that is interesting but not really necessary is in case we have national security confidential data, an emergency protection that could make impossible to get any data of the data center. This feature is interesting, but it's not absolutely necessary. And then we have a data center, but we need to use it. So it needs to communicate with the ground. There are also several possibilities, but I will explain to you. The first one would be a wire connection. It will go from the data center to the ground. It can be a building, an antenna on shore. The solutions needs to get a special cable that will stay on the seabed, like we can see in here. And it will permit the transmission of the information. This solution may be complicated if the data center is too far away from the coast. The second solution would be a wireless connection. Of course, there is no easy way to communicate with electromagnetic waves in the water, especially from the seabed. So to do that, we could imagine a floating antenna on the surface, which is connected to the data center with a wire, and the antenna which is on the surface will have no problem to communicate via satellite waves. The choice between these two solutions has to be made regarding the distance between the data center and the host, and also what speed of communication we need between the user and the data center. Our goal with this project is not to create a whole underwater data center or to determine which solution is the best to be commercialized. We know this already exists. We want to know if it is possible to use only electric power generated near the data center in order to make it fully autonomous. In addition to this, we want to estimate how it is possible to isolate this data center from the ground. Depending on the safety, like we don't want the structure to break down because of the pressure, and we also want that the communication is done well. For the timeline, from here to midterm presentation, we plan on choosing the solution for data center. And after that, and until the final presentation, we want to detail and put numbers on our solution. We split our project into 3 general parts and allocated each one for each group member. Agateo will oversee the safety, Gyu-hyun will oversee the electricity generation, and I will oversee the communication. But of course, we'll not only do this, we will interact. These are our website references, and it is all for my presentation. To finish, have a little discussion. We detailed some solutions using the tidal current and to produce electricity. What could be, in your opinion, the appropriate power generation method for an underwater data center?
The type of tidal method or other
What else? Everything can you
I think maybe it has to be a method that uses technology near the shore, because maybe the data center have to be near the shore. For example, if you have to from the center, it can be in the middle of the ocean, so maybe a method near the shore.
What would be needed?
For example, you talked about the tidal power generation in a lagoon, for example.
The only issue I can see with the tidal power stuff like that is like for data center, we need a backlog of electricity. If there is a like tidal power is like varies during time, maybe with like hydro energy. So maybe they need like batteries or hydrogen source, stuff like that, to have a constant backlog of electricity current to maintain the power outage for the data centers. Maybe like a combination of batteries and stuff like that.
I have an answer for that. It is with the dynamic tidal current.
Investing. By combining Chinese and Dutch expertise, the construction
Here, the tidal dam has a wind turbine on it. So even when we don't have any water movement, we still have we can still expect wind movement. And in addition to the turbine power generation, we still have the wind turbines, which could answer your question. Anyone else?
bigger nuclear station, there's already has a data center, the offshore data center. And I wonder why they did not combine with the self-electricity generation system, like as you guys say. And what is the pros of combining that two systems, like electric generation and data center? Because I think separate them and placed in a proper region is more efficiency. So, can you explain about this?
I read on an article talking about the Highlander. They were planning into changing their electric power generation. They were thinking about the tidal current or even other solutions. So I think the solution is not impossible. They are thinking about it, and the empowerment of the data center will make a lot of economies in energy consumption, because if you produce energy on the coast and you use it in the data center, you have to pay this electricity and also the transfer. If you have your data center in the water and it's a dedicated electric power producing system right next, it will directly use this electric power and not the onshore electricity and make economy.
Right, my comment is that if you want to use tidal power generation, then you need to have a high speed of tide. So the location should be limited, not anywhere. Right?
Yeah, that's right.
And so that also you need to, once again, the system should be the competition should be the land-based data center.
Yeah.
You need to compare it with them. So the competition. So probably it can be again the economic problem or economic comparison.
Yeah, like I said, Microsoft had good results with their underwater data center. The components lasted much longer than onshore data center components, because it has a very good cooling system with the seawater. And also in the end, they will make more money saving using only the seawater to produce electric power, and so also to use it as a cooling system for all the computers. In the end, after a certain time, there will be a winner.
I'm saying that you need to study more focused on economic comparison, because the competition will be the land-based data center. And I saw that another guy from China saying 30% economy. That is big, if it is correct.
Yeah.
So you need to focus on that point. Yeah. And also about the autonomy, I guess it is about energy autonomy rather than brain autonomy or
Yes, energy.
Right? Is energy.
Yeah.
Okay, good.